and welcome to our today's session. Very happy to see you today with us. My name is Alina. I'm an Education USA advisor, and I represent Education USA Regional. As you already know, we are providing monthly webinars about interested topic relevant both for undergraduate and graduate students. And at the last webinar that we had related to the CCC recruitment, by the way, which is still going on, and you can apply for it if you are a student in your high school. So I really recommend those who are interested to apply for this program and prepare for their application for their studies in the US to go on our website, scan this QR code, and register for Competitive College Club. The deadline is 31st of December, so hurry up. There are a few more days, and take the chance to be a student of Education USA. And today we have focused on AI again. I have told you and I have promised you that for this month we will do a lot of webinars related to how AI is implemented and how AI experience might work for you if you will get your studies in the US. So that's why we have invited today a lot of scholars from University of Wyoming, and I will introduce first Margaret from University of Wyoming. So we had with her already a wonderful discussion about how wonderful this presentation is going to be today, and we have a lot of scholars that are going to share with us how AI works on and how is it implemented on the campus of University of Wyoming. So I will just give you the floor, Margaret, and then we can just start with the presentation. Margaret will, I guess, give you more information about all the professors that have joined us today. Thank you very, very much for doing that for us today.
Thank you so much, Alina. Thanks to you. Thanks to everyone at Education USA for hosting the university this afternoon and evening. For us, it's early in the morning, and I'm just so grateful to my scholar colleagues for joining us. I think it's going to be a really rich conversation, and we hope to leave lots of time for questions. So please start submitting those and asking about the things that are most relevant for you as you plan your research and your studies. So I'm so pleased to be joined today by Dr. Diksa Shukla, who's going to share with you a whole host of things that the whole research team that she runs is doing around AI for security, privacy, trustworthy digital interactions, including in kind of the biomedical digital space. Dr. Ben Koger, who's working with AI and remote sensing to study wildlife, which is incredibly important in the national parks of the United States, including here in Wyoming. And Dr. Vinit Katariya, who's working with real-time embedded AI to design smart cities and transportation. Unfortunately, Dr. Kirby is ill and wasn't able to join us, but again, I think we'll be able to go into a little bit more detail about all of these topics as a result. So I'm just going to begin by sharing my screen with all of you and launch into first a short presentation about the University of Wyoming, just to place kind of where we are physically in the United States. And again, why is there this unusual degree of intensive interdisciplinary work using AI in this otherwise relatively kind of small town in the mountains. Just one moment. Great. Okay, so the University of Wyoming. These mountains are about 45 minutes drive from our campus. So you'll see a lot of folks here spend a lot of time outdoors or frequently are working on research and study problems that involve nature and the natural world. Laramie, Wyoming, we're in the mountains. We're up at altitude at more than 7,000 feet above sea level. We were founded in 1886. But there was still a small town. Just about 30,000 people live here in Laramie, Wyoming. And yet there's this unique set of circumstances that lead us to be a real center for research. We are named an R1 Carnegie Research Institution, which less than 5% of US colleges and universities have attained. And part of the reason for that is that we're the only four-year land-grant university in our state. So what that means is when the federal government has research questions that they want to ask, we're typically the primary partner that they're investing in to answer questions relevant to science in Wyoming. In addition, the state heavily subsidizes our university. Because we're the only university in the state, it means that all of the children of Wyoming, the taxpayers don't want their kids to have to leave the state to get a good education. And so the state legislature heavily subsidizes our research. And then additionally, the entire private sector, nonprofits, any kind of research question or problem that the state faces, any kind of recruiting, any kind of partnership, everything comes to the University of Wyoming to solve problems here. And so what we find is that even though we're quite small as a university, we have this heavy research focus and a ton of opportunities for interdisciplinary work to solve problems. Just a couple examples. Our largest employer in the state is the tourism sector. So that's very important. Our national parks, our public land, our natural resources, very important to preserve that for tourism. But our largest economic sector by value is oil, gas, and mining. So you can see how those sectors might be in tension with each other. And yet some of the centers, institutes, and labs here on campus are working specifically on those problems to say, how do we use and preserve our natural resources for all of these economic reasons? I just want to center kind of where we are. Some folks, you may not have heard of Wyoming, but you've probably heard of Yellowstone National Park. Or you've heard of the Mount Rushmore National Monument. You've heard of the Rocky Mountains. You've heard of the city of Denver. So I'm just going to play a really short video that kind of centers where we are amongst all of these more famous places. So you can see kind of where this research is happening and where future students would be studying. So you can see, again, there's mountain ranges that run all the way from Mexico up through Canada. We're right in the middle of that sear, that kind of crumple through North America. Those mountains surrounded by public land, but about a 2-hour drive to the Denver airport. Again, because we have this really significant investment, we have a 13-to-1 student-faculty ratio, average class size of 30, and just under 11,000 students. Who else would be there at the University of Wyoming? Who else is studying there in addition to studying with these amazing professors and researchers? So again, because the state has so heavily subsidized the education here, about 70% of the students are from the state of Wyoming. About 25% are from other states and territories. And then just 5%, about 4.9% of students are from more than 80 countries all around the world. We're also very unusual in that we're pretty heavily concentrated with a lot of graduate research. So about 24% of our students are graduate students getting their master's degree, their PhDs. Sometimes there's advanced graduate certificates in particular areas of expertise. And we also have really unique opportunities for undergraduate students to be involved in research. So again, so many of the same multi-million-dollar pieces of equipment, so many of the same really exceptional kinds of research that is happening, but much greater access to be able to participate in that research. And every year we have undergrads that do get their names into published papers because they participated with their professor. Their professor saw, hey, this person might be a junior or a senior. They may not be doing graduate research yet, but they have the ability to contribute to kind of our understanding this problem better. And this is pretty unusual, even especially at R1 research institutions where you just wouldn't get that opportunity to participate. Majors and programs, I won't go into everything, but basically we have more than 200 programs total, more than 90 graduate programs and master's and doctoral degrees. I'm happy to share PDFs with folks who are interested later in the list of all of our more than 200 degrees. But I think it's really important if you go to our website to just look and see how many different programs you can start with a bachelor's and then move through your master's and your doctorate all at the same university. And again, that really creates an incredible intellectual learning kind of ecosystem where no matter where you are kind of in your journey, there's going to be people with more experience and expertise helping you along the way. Last, I'm not, again, going into a ton about financial aid and how to apply because that's not what this is, but we do rank very highly in our ability to kind of help students afford to go to university. So with that, I've kind of set you in the context of kind of where we are in Wyoming, some of the really drive our work, and again, why we're able to attract such important practitioners to this small town in the mountains to do the work that they're doing. So first, I'll turn it to Dr. Diksa Shukla to present about the work of her research team and how they're using AI to solve and investigate a whole host of problems across privacy issues. Dr. Shukla, over to you.
Okay, hello everyone. Thank you, Margaret, for introducing me. My name is Diksa Shukla, and I'm an associate professor in the Department of Electrical Engineering and Computer Science at the University of Wyoming. At the university, I teach artificial intelligence, machine learning related courses, and cybersecurity related courses. So since we are talking today AI for social good, I want to give you like a peek into some of the projects in my research lab myself and my students are doing. I will keep it like, there is no slides, no equations, no pressure. So I will just provide you a very brief introduction. The one of the project we are doing related to AI application. Before that, let me just, my research lab is Secure Sensing and Learning Research Lab, and I do have multiple PhD students, postdoc, and undergraduate students who are working with me in my research lab. So coming to some of the projects, one of the project we are doing, which is like, not looking at the applying AI, but looking at how we can make AI models less slow and less expensive. So you have probably seen some of the apps that can describe like, photos or answer picture. If you show a figure, the AI can tell you what it is about, and it can describe that. And you can ask some questions about this scene or picture, and it can tell you the answers. Like, for example, how many objects are there, or how many round objects are there, how many of which object, like, if there is an object of this shape in this scene or something, or if there is a bicycle in the scene or something. Those kind of questions you can ask. They're really cool. But they are often very slow and sometimes inaccurate. Because they use a lot of computation, they require a lot of energy to compute, a huge amount of computing power. So we are working in our lab that helps these models behave more efficiently, basically teaching these models focus on important part of the images first. Instead of trying to read every pixel in the image, we are making the models to make them learn about what could be the important portions of the image, and focus on those pixels first. Think like learning when you are going to read a book. First, skim the book, and before you start reading the book, right? So, reading a chapter, before you deep dive into the chapter, you can just skim the chapter first. So why this is important. This project helps cut down the computation cost very drastically. Faster AI means more people can use it, not just like, big where you have big servers and big computation resource. So common people can use it. So that is why it is important. Let me introduce to. So this is what we are looking lab, how we can make AI more accessible, less slow, and less expensive. The other project I will go is the using AI as well as applying machine learning and artificial intelligence techniques to utilize for security. What we are doing, we are basically think about, instead of logging to your computer or your mobile phone or any other computing device, instead of using your face, fingerprint, passwords, we are developing systems to use just your brain. So we are using EEG, basically acquired brain signals from the scalp itself, and use that brain signals to develop how unique every individual is. And that can be used as identity. So for example, if I have to log in to my computer, I don't need to provide my face, because face can be spoofed. Someone else can steal it and use my face to log into my system, our fingerprint. So what we are doing is we are developing systems. So instead of doing face or fingerprint, our password, someone can steal your password. So your password is pretty simple. Someone can just break that or guess that's the password. We are developing system that when you interact with computer, it uses your brain signal to find out it's you, not someone else. So that's one thing, to build the identity. Not only brain signal we are looking at in our lab, we are also looking at different behavioral biometric or behavioral patterns. Like for example, how your hand moves when you are typing on the phone, right? So how your hand movement, how your fingers are moving, or how your wrists are moving we are finding that that's pretty unique to individuals. The other things are like, how your eye movement is unique to individuals. How you walk. Have you seen someone walking and you recognize who is that from very far, because their walking pattern is very unique. So we can utilize those walking pattern if you're walking with your phone, or you're walking in any virtual reality environment, our augmented reality environment, and you are just the system can use how you're walking to identify it's you. It could be cool application when you are you are walking with your phone on your pocket or in your bag, and it sees your walking pattern and finds out it's you, not someone else walking with your phone. If someone phone, it knows it's not you and it's someone else walking with your phone, so it can take necessary steps. For example, like erasing or blocking all the private or personal data. So those are some of the gestures we are using, or behavioral patterns we are using. So basically in the lab, what we are looking at, can we use these everyday behaviors to authenticate or identify people automatically and securely. Basically, for example, imagine picking up your phone, it already knows it's you, not because of you entered the password, but because it recognizes how your hand moves to pick up the phone. When you are interacting with the computing device or any device, it is reading your brain signal and it is finding it's you, not someone else. You're typing on the phone, or instead of using your fingerprint, it uses your typing behavior. So that is another project we are doing. But at the same time, when we are talking about providing people secure access to the devices, like not someone else, or adversaries cannot access your device or have hard time to access the device. But at the same time, it is important to find out what are the existing vulnerabilities in the system. So we are looking at side channels, how side channels, like for example, not the direct communication channel to the computing device, some other information leaks from the other channels which are not direct communication channel. For example, if you're working on a AR/VR device, you have a AR/VR device, you put it on, or you are just typing on your phone, someone else just looks at your phone from the side, just shoulder surfs you and find out what you're typing. Or someone else just looks at from front, they are not looking at your phone, but they look at you are holding the phone and you are moving the fingers. These finger movement can reveal what information leak can be there, right? So this is another project we are looking at. What are the information leak? Where could be the privacy leaks? Could be there. and then take the preventive measures, develop systems so that we can prevent these leaks. I would also introduce one other project in my lab. We are looking at, so Parkinson's disease is, very many people suffer from Parkinson's disease worldwide. What we know is, with the onset of Parkinson's disease, in some time or some years, the speech impairment happens. But the research shows that through therapy, this speech can be improved. So finally, we are doing this project about when people with Parkinson's disease struggle with speech. This therapy can help, but it is not accessible and can be difficult to access the therapy because of the access to speech therapist. So we are creating video-based automated AI environment where people can do therapy sessions with practice themselves in a more controlled environment, as well as have AI assisting them for this therapy. We are doing both just the video environment and more immersive AR VR environment where you have a therapist VR avatar assisting you with the mouth movement, basically lip movement, to practice larger movements so that your speech can be more clear. We are doing that. You can do this kind of therapy sessions privately from your home and securely, and even it reduces the burden on therapist, and makes it more accessible because you can do it from anywhere. Just you need a device of phone with camera as well as internet connection, or for therapy you do not need even internet connection. So why I told you this, I'm sharing these stories because I want you to see it's wide and creative AI applications. In the same lab, we are speeding up AI, big AI models, making them more efficient. We are using brainwave and other behavioral biometrics or behavioral patterns. For security, we are looking at how much information leaks are there. We are also developing video and AR VR based solutions for Parkinson's disease people with speech impairment for therapy. All of this requires artificial intelligence techniques to be assisting. So that's the fun of this field. You can mix technology with healthcare, psychology, safety, security, gaming, art, anything you care about. If you take one idea at home, you do not need to know everything. You can start with one idea and just being curious. So thank you for listening, and I would stop now. Thank you.
Thank you so much, Dr. Shukla. That was really incredible, and I feel like it's one more example of how we are living in the future. So now I'll pass. To Dr. Koger. Dr. Koger, I'm just pulling up your presentation, so go ahead.
Okay, I'm unmuted. Hopefully people can hear me now. Yeah, so as you just heard, my name is Ben Koger. I'm an assistant professor in the School of Computing in the Department of Zoology and Physiology at the University of Wyoming. So yeah, I have this great dual appointment where I'm both in the School of Computing, where I can really focus on computational methods and developing kind of AI type approaches, while I'm also in the Department of Zoology, where I can really think about kind of the applications in regards to wildlife. And that is the focus of my work, is how I can build and use new AI and computer vision tools to study the environmental world in ways that previously haven't been possible. And so for me, this picture on this opening slide really illustrates why images are such a powerful tool for studying the environment. So this is, all those animals are zebras in Botswana on one of the world's largest migrations. And you can see just how much different types of information are embedded in an image like this. At a minimum, you can just count how many animals, happen to be there. But we can also see there's very variable landscapes where on the left, there's lots of water. On the right, there's this grass. In the middle, we have this area for walking. And we can see exactly how the animals are placing themselves within that fine scale landscape, and the social interactions between the animals as well. We can see they're not just randomly distributed. It seems like there are clusters of individuals that are maybe moving together. And even these trails where the animals in front seem to be influencing and physically changing the environment that the animals behind them are moving through. And so that's just an example of in a single image how much information there is about these animals and how they're using the environmental world. And so what I'm really interested in with my research is, if for every image as a human we have to look at these images and record exactly what's happening, that's a very slow process. But by using a lot of these new AI methods, we can much more efficiently go through huge numbers of images and really start in a scalable way, again, understanding the animals, their natural world, and then importantly, thinking about the interactions between how humans are using a landscape, how animals may be using a landscape, and then thinking about how can we, have all the human development that we need, while also making sure animals hopefully maintain what they need as well. So next slide, please. I'm just going to very quickly talk about a couple of examples of how this actually works in my own work. So the previous slide had an example from Southern Africa. This is now an example from Wyoming, from actually relatively close to the university. One of the animals that lives across the state and across Western North America is something called pronghorn, which is kind of like an antelope, but is a little bit different. And researchers, both at the state, the federal government, and other entities, are really interested in just how many animals actually exist in different places every year to make sure that these populations remain healthy. And this is over millions of hectares, a huge area. And traditionally, people have literally flown airplanes very, very low, just 100 meters above the ground, and looked out the window to try to count these animals, which is not a very efficient or scalable process. And so what we've started doing instead is mounting high-resolution cameras on these airplanes, getting images like you see on the left. So that's a very high-resolution image of a big chunk of landscape. And then we can train these AI models to automatically detect many of these pronghorn in each image. So again, across millions of hectares, we can find most of the pronghorn in these landscapes and actually understand how many are there. Is that more or less than last year? Does it seem like this population is doing well, for example? And that highlights another aspect that is important in my work is, it's one thing to be able to detect animals or any object that you want of interest in these images. That's something that's people have pretty good methods for. But what's becoming more and more clear with these AI tools is that while it's maybe not that hard to get good performance, you're almost never going to have perfect performance. And so something that's really important is thinking about how can we actually efficiently validate and quantify the uncertainty of these models in real world applications. And so thinking about doing that validation efficiently is an important question. Next slide, please. And so I just want to finish up on kind of 1.5 more examples here of thinking about the different scales we can use these methods. So previously in the last case, I was talking about huge scales where, again, so we're talking about millions of hectares, thousands of animals, and figuring out how can we just understand how many are there over these areas. But we can also think at much finer scales. So instead of using airplanes, we can use drones and actually just hover over groups of animals. So in this particular example, we're looking at zebras in central Kenya or gelada monkeys in Ethiopia. But these methods work for all kinds of different animals, whether you're talking about elk in Wyoming or any other sort of thing. And so we can fly these drones over these groups. We can use these same sort of automatic AI detection and tracking tools so that we can watch now not how many animals are here, but how these animals are moving together, what their behavior seems to be, what the social dynamics are as they're moving over these landscapes over the course of, say, 45 minutes. And so then we can really start to ask fine-scale behavioral questions about, again, not only how are these animals maybe working with their natural landscape, but say if we had human fences or cropland or things like that, how can we understand both how to protect the human development, make sure that crops aren't being eaten, but also make sure that the animals are able to use the landscape that they need. Next slide, please. And so this is just one example of a different context where we're doing these sort of things. This is now up in Alaska, so way in the north of North America, where we see this brown bear hunting all of these red salmon, these fish in this pond. And this is just a still image, but this is coming from a video where, again, we can track each one of these animals, not just say how many there are, which is an important first question, but also what are the dynamics and what does that help us learn about these animals and how humans can use the landscape in a way that hopefully is good for humans, but also good for these animals. And then next slide. So that's all that I wanted to say for now. That's just a very quick summary of the types of things that I'm interested in, and I'd be happy to talk much more in the questions about any details of this work.
Great. Thank you so much, Dr. Koger. And now we've moved from kind of some of the most intimate uses of AI for social good to these broad, wide-scale wildlife and across millions of hectares, understanding what's going on. And now we're going to move more towards urbanization and transportation with Dr. Katariya. So, sir, over to you.
Thank you so much, Margaret. Today I will be just quickly talking over about some of my work that I have done in the last few years. First of all, good morning, everyone. My name is Vinit Katariya. Good morning, good afternoon, good evening. And I recently joined University of Wyoming as an assistant professor and in Department of Electrical and Computer Science and School of Computing. My research is at the intersection of AI, computer vision, smart city, and intelligent transportation. And I just quickly want to cover something like computer vision is basically a branch of AI, is a branch of AI that helps computers figure out what's happening in them. Right? For example, when your phone unlocks using your face, basically that's computer vision. When you use Snapchat and you add filter, and that's what is computer vision. So basically, any kind of AI looking at photos or videos is basically what is computer vision. So that branch of AI is called as computer vision. So let's look at the big picture here and what my work entails. So the thing is, if we take a step back and we try to think about it, we kind of see that cameras are everywhere. And each camera, like in cities, even on highways, you must have seen so many cameras, right? And each camera has some kind of computer vision or AI application attached to it. But what happens is gradually the use of AI reduces, and eventually these applications are just used by, and these camera feeds are just used by people sitting in a room looking at different screens and trying to evaluate what's going on. And even after having this huge infrastructure, safety is still a concern in cities and highways because we all know that number of accidents are rising, number of fatalities are rising, right? Even we keep hearing about rising criminal activity. So the underlying message here is that the infrastructure, the camera infrastructure, sensor infrastructure is kind of underutilized. Next slide, please. Next slide. So basically, this is where the opportunity lies. And what we have realized is like there are 85 million cameras deployed for security purposes across US. And so what we are trying to do here is the overreaching goal is to bridge the gap between AI innovation and actual safety outcomes in the real world. And I approach this with three different objectives. Like first is building safer communities. So the higher main goal is we have to have safer communities because at the end of the day, AI isn't just a technology. It's about improving the quality of life and saving lives, right? The second is, as I mentioned before, leveraging the existing infrastructure. We already have millions of cameras and sensors, as I mentioned, and the challenge is how to make smarter use of them, so that so that we can move on to the third part, and that is developing. I call it developing computer vision framework. So I explain what is computer vision. Framework is basically nothing but a piece of software or a piece of code, I would say. And it is usually modular. It is step by step. So we basically develop framework. We have different applications, and I'll show in my next slide that how the framework works. So right now, what's happening? Like, let me take this example of work zone safety. What if you look at the image on the left hand side? What's happening right now in work zone? So work zone are these zones when you are driving and when on the road, you can see that some people are working on the side trying to fix the road, trying to fix something on the road infrastructure. So that is a work zone where people are actually working. Now, the number of fatalities happening every year in work zone is rising every year. Just start from 2023, you can see here at top right, 176 people lost their life. Like people who are working in the work zone lost their life. So the current tech is, if you look at the left-hand side of the image, the current tech is basically takes the video, sends it back to the cloud, it calculates something and then sends back the results, right? So it's trying to evaluate what is danger to the workers. However, this sending the data to the cloud and coming back from the cloud itself is very, very fast, but this data sending and receiving of the data can be a bottleneck. So if you have used AI, you ask some questions. Sometimes because of the bad connection, it takes more time, right? So even if text take that much time, the video takes more time. So the solution, I call these solutions on left hand side like passive methods. And what we propose basically when I was working in this field is let's propose an active method. So in active method, what we are trying to do is we are looking at the incoming vehicles. We have a camera. You look at the incoming vehicles and you try to predict where this vehicle will be in next 1, 3, 5, 10 seconds, right? And we keep matching the actual vehicle path with the predicted path. So usually how AI works is it tries to predict what will happen next, right? And if the actual path deviates from that predicted path, it means that something is fishy is going on. On the right hand side, this new figure that has shown up by framework. Framework is basically a collection of different modules. If you see in this figure, we have an object detection module. The output of object detection module is basically you can see different cars, different objects have been detected. Then it goes to the tracking module. Now, video is nothing but a series of images. So what happens is if I detect a car in one image and the same car appears in second image, you have to make sure that, and the computer doesn't understand that it's the same car. So AI is that's when AI comes in, and it makes sure that it understands that the same car is across different images. So that is called as object detection, and the second part is tracking. So framework is basically a collection of all these different modules. If you look down in this, you can see there's filtering. So we are just trying to filter out if there's any noise in the detection, and then we have something called as trajectory prediction. In the second row, the first block is trajectory prediction. It means that we are predicting the path of these vehicles and then trying to understand if the vehicle will come and hit someone. Is there any kind of fishy behavior that vehicle is showing? And that's what we are trying to do. Next slide, please. So here I have shown you an image of how this works. We are looking at the video and a car comes in and it starts approaching towards the work zone, for example. And then the AI starts telling us, oh, there's an anomaly. So basically what we are trying to do using these kind of application is alert the workers in the work zone that there's a car coming that way. These few seconds that they can get because of these kind of alerts are really valuable because they usually get 1.5 seconds to react to a vehicle coming towards them. And that's what has been causing a lot of fatalities and a lot of injuries. So what we are trying to do here in this application is we are trying to increase that window. We are trying to give them a few more seconds by predicting the vehicle's behavior and giving them some alert. So this is just one of the application in transportation. If we move on to the next slide, we will look at some of the public safety application. Now, by public safety, what I mean is, in a lot of cities, you must have seen these cameras on the side, right? Most of these cameras, as I said, are used by cities where people are sitting in a room and looking at these videos. What we did is, to each camera, we attached a piece of AI which detects what's going on in the scene. Now, I say privacy preserving public safety is because in our research, we were well aware of that people are kind of sensitive about cameras looking at them, identifying them. So we try to take the privacy part very seriously, and we removed all the information. Any kind of face recognition was removed. Any kind of identification was removed. And if you see here in the image, the video goes into the AI system. You can see there are different nodes. So each camera is one node, and the output of this AI system is basically something you see on the right hand side, where you can see, right now the normal frame, the person is standing, nothing is going on, and what happens is this person enters the scene. Now this anomalous frame. So it means that some kind of anomaly has happened. Something normal is not happening, and that's what we are trying to do. So you can see that there is no identification in that. So that's what we did in privacy preserving public safety. We developed different AI algorithms to remove all the part from, like, all the identifying part from the image. Then we use another AI algorithm to make sure that we identify what is normal and what is not normal going on in the frame, and then detect that. Now you can see a mobile phone sign there. So we also developed an app where this kind of alerts will go to the people, and they will be able to take some actions. They will know exactly where this kind of anomaly has happened, and they can take some action. Maybe, if there is some kind of accident or something like that, they can call the medical services or send the police to the location or something like that. So these are the kind of applications I have been working on until now. Next slide, please. So this is all I talked about cameras, right? But there are different kind of modalities. Modalities is nothing but inputs to the AI system, and there are different sensors available out there. So camera is basically an image-based sensor, right? It takes in the image and gives it to AI. There are different sensors available. For example, there's something called as LiDAR, which is nothing but it sends out laser pulses and receives by what is there in the environment. So when you combine this with camera, you get more information, like how the vehicles are moving, what is this exact distance of these vehicles, or what or the object that you're trying to detect. So that's LiDAR sensor. We are trying to use LiDAR with camera. Another important reason of also using something else than cameras is at night. You can see that in different situations, cameras may not be helpful. So for example, at night, camera may not be able to see a lot of details. So that's why we move on to other inputs like thermal or infrared cameras, right? So that's when these kind of inputs come in. In my lab, we are also trying to explore some really radical inputs. For example, just using Wi-Fi signal. We are trying to use Wi-Fi signal to detect any kind of action that person is doing. It sounds radical, but with this AI technology that is coming up, we can do that. We can train AI models along with the images of the room and Wi-Fi signal to understand, okay, if this kind of Wi-Fi signal comes up, this is the kind of action that's going on. So that is also what I'm doing in my lab right now. So you can see what different kind of things we are doing at University of Wyoming. And basically the aim here is with proactive AI, not just using AI, but using it for safety of real world. So that's my presentation. Thank you so much. And you can reach me out with any question you have after presentation on this video. Thank you so much.
Thank you so much, Dr. Katariya. That it's really, these three presentations were amazing and exciting about all of the kind of work that you're doing. If students are interested in learning more about studying at the University of Wyoming, also please feel free to reach out to me. And with that, Alina, I'll pass it back to you for Q&A. I'll also just mention I do have a survey. If you'd like, I can put it in the chat. If students have particular questions or want information to follow up on particular topics, I'm happy to put that survey in the chat as well to be able to send out personalized information. So
that would be great. Yes, please, you can do so. Great. Thank you so much, everyone, for presenting your area. That's very, very appreciated. We will just select 3 questions from those that we have got in advance, because the students have the possibility to address their question. One of them, the first one actually, is if University of Wyoming offers any scholarships. So I think that's about Margaret. So if you can just advise our students, both graduates, both undergraduate students who are interested to apply, if they have some chances there.
Absolutely. So we, at the undergraduate level, we have automatic scholarships based on GPA for all students. So if you have at least a 3.0, you get $5,000 a year, renewable every year, as long as you keep your grades up. And if you have at least a 3.4 GPA equivalent, you automatically get $8,000 a year. You can further reduce the cost of attendance by getting a part-time job up to 20 hours a week. Those usually pay between $12 and $17 an hour. And then by moving off campus, you can kind of share housing with your friends. And the cost of living in Wyoming is pretty low compared to other parts of the United States. So that's also a way to make your undergraduate education more affordable. At the graduate level, it's very competitive, but many of our graduate programs have fully funded graduate assistantships. I would say most, in fact. And so you would receive a graduate stipend in exchange for teaching or research, which again, the teaching training that we give teaching assistants and the research experience, that is really, you get paid, you can afford to get your master's or doctorate, but that's also frankly really invaluable experience for whatever you want to end up doing, whether in teaching or research with that graduate degree. So those are the main ways. I would say at the undergraduate level, there's less financial assistance, but it's less competitive to get in. At the graduate level, it's extremely competitive, and we generally have fully funded graduate assistantships.
All right, thank you so much. The other question, what's one use of AI you hope the citizens adopted quickly to? So as everyone of the professor already have spoken about how they use it and how this is social beneficial, I think we can just offer a general question. If there is one of the professor that maybe can share one more example, maybe that's, even though I've understood somehow how you are implementing that. So maybe someone wants to add something else that he or she forgot during the presentation and would like to. Yeah, sure, Ben. Thank you.
Just very quickly, not exactly related to my research, but the kind of pre-built large language model AIs have been getting way more powerful since they've been released. And I've noticed a lot of people who first tried them and didn't think they were that useful. And I would say in the past couple of months, at least for myself, they've gotten way more useful. And so I would just throw out there, I really encourage people and see what they're able to do with what you're already interested in.
Great, thank you. Thank you so much. I don't know if someone else wants to add something. I don't know, Dr. Diksha.
I can add quickly about, I think I would, yes, large language models, multimodal large language models are very useful, but I think I encourage people to think about how these models are helping them instead of basically augmenting their skills, not replacing their skills.
Great, that's great advice. And one of the last questions that we have from the students who have addressed them before is, how will artificial intelligence influence our lives in the near future? That's a very common question, I think. It's a general one, but maybe we can just choose someone to respond to this one. I don't know,
Yeah,
Dr. Vinit.
Yes, sure. I think AI is gonna influence in life in a lot of ways. For example, now everybody's going to have their own assistant. I think that's awesome, right? You can just have somebody do some work that you feel is boring, and it's going to do for you. So we'll have a lot of assistants going forward. I think that's a huge change. Everybody will have access to this. A lot of these models, as Ben mentioned, they're free, right? So I think it's going to be a huge change. You can use them, as Diksha mentioned, to learn something for yourself. And she mentioned this is not just for replacing. I mean, this is not for replacing people, but this is for making us more productive. We can use them to make better version of ourselves. So I think AI is going to do a lot of good. And as I mentioned, like in my presentation, it is also being used for a lot of social good, for safety applications. So I think AI is going to be ubiquitous everywhere. It's going to be everywhere, and it's going to make our lives much better in future.
Really hope so. I mean, that would be really great. That will have only benefits from it. And what do you think about AI affecting the quality of education and the quality of the students? I mean, the students which are studying currently. Does that affect the process, their academic success or not? What do you see from the recent times?
Yeah, I'll just go and one example I'll share with you. When I was
Sure.
studying, when I had doubt, I had to wait for the TA session. I go to the teaching assistant, ask them question. If they can't answer, I go to the professor. Now, you don't have to do that. You can just ask AI. The first level has changed now. The first level is not waiting. The first level is asking AI, okay, this is my question. And it can help you understand what's going on. If you don't understand there, then okay, of course, you can go to the teaching assistant. So that first level of waiting has gone. You can just quickly, jump these hoops. And I think it's going to accelerate the learning. That's how I look at it. I have any doubts. That's what I try to do. I try to ask AI first, and then do my own research. That's just my take on it.
Okay,
I think
that's
students are
very
going to be more
helpful.
successful. Yeah.
That makes sense. Thank you so much, everyone, for joining our today's session. We really appreciate how everything is applied within your institution and how AI specifically is applied and what benefits it brings to our society. That's priceless, I think. And I really hope that more students from our region would eventually explore the idea of applying maybe also to University of Wyoming, which also offers great scholarships, as Margaret have said. So yes, if you'll need more details, if you'll need us to share the presentation that has been done today by the professors, let us know. We will do that. As soon as you write to us. And yes, thank you so much to all the professors that have joined us. Thank you, Margaret, for the wonderful presentation. And yes, we really hope that we'll collaborate in the future for more events. I have heard that you have mentioned that there is oil, mineral, and gas that you are also focused on, and we plan to do some webinars on that because there are students in our region who are interested also about those fields. So yes, we also share the survey that Margaret have mentioned in this chat. So please access it in case if you are interested about universities of Wyoming. Thank you once more. I wish you everyone a great evening, and thank you so much for joining so early this morning. I really appreciate that. Have a great evening, everyone.
Thank you. Bye.
Thank you.